Yo, okay. So, we've had so many engineers talk already. So like, I guess, I feel like you guys get that aspect, just the engineering side of things. I am in electrical engineering. My name's Cal, the usual. I'm at UNSW. I'm in I'll just say last year, we don't need to know how long it took me, but I am in my last year. And so I'll be talking about electrical engineering, telecommunications. I'll try to stray away from the engineering side of things, because what you guys will find, or what you've probably already seen, is engineering as a discipline is very similar in terms of the technical skills that you guys will be dealing with, very, very similar. So let's get started. Can you summarize? Honestly, answer to this, no, I cannot. It's very broad, yeah? Unlike aerospace, which is what Michael does over here, aerospace, super specific, very, very streamlined, very focused. When you guys go into electrical engineering, you'll see that there are a lot of sub-disciplines, and at the end of the day, you can honestly go to so many different things. It will take hours just to even scratch the surface. So what I'll try to do is just give a very relevant or somewhat of a relevant example in each of these fields, sub-disciplines. So, electrical engineering, it encompasses a couple major sub-disciplines, right? So we have power engineering, control, electronics, signal processing, telecommunications, which is what I'm in. And those are the main ones that is actually offered at UNSW. These other three, honestly, they're either like sub-disciplines, or I've just not really seen them offered at UNSW. So the thing is, let's say, what is power engineering? Any kind of electricity or any kind of power generation, that whole process, there are a gajillion engineers along that whole line. So whether it is electricity distribution, right, along these lines, electricity generation back at the power plant, all of these places will generally need some kind of electrical engineer. And I guess that's one aspect that you could focus in, right? Another one is control engineering. Now this one's super vague, but you guys will actually find this overlaps a lot in mechanical, in mechatronics, in chemical even, because control system engineering is just a discipline of engineering where you design literally systems, yeah? And it's like, what the hell is a system? This is probably the easiest one that every lecturer gives to a student. In this case, it's like the cruise control, right? Who designed the cruise control system, and how does the cruise control system work? Generally speaking, that system is designed with some kind of controller, some kind of brain, and a bit of code. And on that side, what happens is it takes in information from sensors, and with the information from sensors, it will adjust whether the car needs to speed up, slow down, depending on what you've set the car to go at, right? That's control systems, and that is so vague in a sense where you can apply that anywhere. You can go into like a factory and manufacturing process, and you can describe them with systems as well, and all the theory there. The next one, electronics and microelectronics. Honestly, just one thing. Electronics is just literally everything. Like anything electric based, like your phone, laptop, everything, electronics based. And then microelectronics is smaller electronics, right? And so in that case, super broad as well, but that's the super typical one. I think that's the one that everyone might think about when we think about electrical engineering. Signal processing, to be brief, because I don't want to go too far into this, but signal processing is just when you're dealing with how is it that signals being like voices and many other forms, how is that actually transferred and transformed into something the computer can understand, right? So how is it that I can speak into a microphone and then like all these waveforms pop up on my computer, and I can send that MP3 file over, put it on a hot beat, and then maybe share my mixtape or something like that, right? But how is it that my voice, this sound, gets into the computer, and how does the computer actually understand all that stuff? Yeah? So that's in signal processing, you're processing signals. And then the last one, which I'm in, is telecommunications. So very straightforward, right? Telstra, Optus, NBN, all of those companies, right? And so many more work with how is it that data is transferred. So once data is already in the system on your computer, how does it actually get to the other person's computer? How does it get to a different country? How are these networks actually combined or connected? Whether it's through wires, right? Or whether it's through wireless networks. So that's generally it. That's a general, super like scratch the top of the surface introduction into these majors that I'm familiar with. Now, the other side of engineering, which I said I was just going to skip over, is design. And these guys have said it before, you're designing a lot of things. And you also hear like, engineers, they solve problems. They solve problems by designing things. It's like, hey, you have a problem? Let me design this circuit, fix your problem. That's generally what you guys will find yourself doing like towards the end of your degree and so on. And this is like a general process. It's like, customer needs a solution to a problem. And then you go through all these steps to identify how is it that I can build something in my discipline, whether it's in signal processing, electronics, or whatever it is, to actually cater to that customer. Yeah? Realistically, this is what you will do when you actually get a job in different companies. Yeah? Companies, which I'll talk about in a second. Yeah? Day-to-day, straightforward. I'd say there is a departure from high school. It's not very similar anymore, where it's like you guys have a tight-knit cohort like some other degrees might have. But the day-to-day is very straightforward and it's very structured. You have lectures where you learn your basic stuff, yeah? Learn all your content. You move into tutorials where smaller classes, like maybe the size of this class, right? Where someone will help you work through the content, like answering theoretical questions. And then the majority part of engineering, which is labs. I don't have a picture here. Actually, I might. Labs, right? You actually have to take the things that you've learned from the lecture and show people, hey, can you build this using the knowledge that you've learned? Do you actually understand it? Because the understanding part in engineering is really proven by application. Can you apply this? Can you build this? Can you design that? Yeah? Super important in that case. So honestly, spend a whole bunch of your time here. This is compulsory. Can't really get out of it, unlike lectures you might. But yeah, regardless, engineering, very heavy, just like what Howie and Michael have already mentioned. Now, how does it compare to school? The spoon feeding stops, right? No more. You don't rock up to lectures, that's your problem. You don't understand it, that's your problem. But luckily for you guys, you have so many resources. Find myself getting acquainted with a lot of these Indian tutorials. They help a lot. They actually are like the backbone of most degrees in engineering. They are so helpful if you don't tend to go to uni and listen to your lecturers. Or maybe your lecturer is bad, I don't know. Or maybe it's just my fault, I'm an idiot, right? But you will find yourself Googling a lot and doing a lot of self-study, yeah? And that's something that I 100% believe is not the same as school, right? You're not really told what to do in that sense. You have to really build the structure yourself. The other thing is a lot of help, yeah? This is just a little group chat. I feel like I find myself saying this a lot. I'm just like, I send it to my boys, I'm like, help please. Another hour, I'll just say, some more help please. Just help is in general. It's like everyone has said here, it's like networking is so important. You just need a support group, right? I'm just like, sometimes I'll go in the lab, and you guys will see, look, oh my God, forgot what an op amp, how does that even work? And that's literally what you learn in first year. And I'm like, bro, I'm actually so lost. Why is everyone so smart? And that's what you generally feel, yeah? I just want you guys to understand it's okay. And this is why networking is so important, to feel like, or to have some kind of support structure. When you feel like that, because honestly, my first, second, and third year, I didn't really have that kind of support structure, and I really found it like troubling, right? Very, very difficult, whatever degree you do, if you don't have friends in it. And it's not even, you don't need to be like 100 billion friends. You just need, 5 or 6, some smart people just to make sure you can bounce some ideas off them, yeah? Why did I choose it? Definitely not because I thought you make a lot of money in electrical engineering. Definitely not because I thought, oh yeah, this is the hardest one, let me try to do it. Yeah, like I'll be full respected and like whatever it is. Definitely not that, definitely not that. If you guys are thinking about that, don't, yeah? But realistically, I think the one thing, the takeaway, one of my successes, I guess, is the reason why I picked electrical is because it's super broad. And I tell this to all my students, it's always pick something as broad as possible if you are lost. I was lost, yeah? Not everyone has the chance of being so laser focused into what they want to do. And so I didn't really know, and I just picked electrical. I was like, oh man. And yeah, for sure, I didn't enjoy the first 2 or 3 years, but because it was so broad, I eventually found a little niche. Oh, just like what Justin did, right? He found computer science in electrical because it's so broad, and he ended up just going there. And for me, I found telecommunications, which is a bit more interesting than whatever the heck I was doing in electronics or whatever the other side is. And it's like, oh, not bad. I didn't have a direction, but I chose something super broad, as many opportunities as possible, and then hoped to find something. And honestly, it works out, right? It's probably one of the better plans. What type of person? If you do maths, if you do physics, obviously 4-unit physics, it doesn't really mean anything. There's very little translation because you learn your foundation maths in first and second year. You learn the uni level maths, and that's going to be the foundation. Although it's a nice bonus, yeah. What I actually do recommend, I'll take it as an example. One of the smartest, the most exemplary student in my cohort, or that I know of right now. I think in the degrees that you do, especially in engineering, it's very practical. You have to be curious and hands-on. He is so practical. He has a YouTube channel where he takes electronic devices and he fixes them and he makes like a vlog and he's like, oh yeah, I found this thing and oh, this is how it works. And It's crazy. Like he gets that curiosity, you can see it, and I honestly believe that's the reason why he's so successful. You don't need to be at that level, but you need to have aspects of that, right? Very practical base. So it might help in first, second year, but you need to translate that over to something more hands-on, right? Like in all engineering, like how Michael's in all of those student-run teams and stuff like that. Those opportunities are available. Yeah. What career paths? Now, like I said, engineering, electrical engineering, so broad, so many things, so you can't even, it'll take ages, but I've taken just a simple example from each, yeah? From those majors that we talked about. Power, work in the power system, whether it's back at the power plant, whether it's in substations or whatever it is, right? There are opportunities everywhere for you, right? Or honestly, you can go into construction. How does this building get electricity? How does this building actually connect to the wires outside? An electrical engineer needs to manage that, design the system, all of that good stuff, yeah? NBN, not the best example, but NBN, rollouts of internet, right? And just anything telecommunications based, internet based is mostly, is going to be an opportunity for you. Signal processing, the example that I'm gonna use here is very specific, but it's a company that works very closely with UNSW, and it's Dolby, right? And they design software to then, better enhance your listening experience. And that is all signal processing, like your equalizer on your phone, equalizer on your computer, whatever it is, that's all signal processing, that's all coding. And then that last one, this one's also specific, and don't think that this is the only thing. Yeah? In electronics, you're building small circuits to do certain things. And so in this case, another company that works closely, so it's fresh in my mind, Cochlear is just a company that designs all of those hearing aids, right? They build those hearing aids, and just a lot of my friends have gotten internships there, and they've just reported back, so that's the most fresh in my mind, but literally can go anywhere with this. Yeah? So electrical engineering, super, super broad, but these are just some of them. Yeah? Common misconceptions, like if you're smart, like theoretically, you're gonna kill it, not really. There is some aspect of it, but like I was saying before, practical. All these engineering disciplines that we've talked up here about, super, super practical. And if you don't have that, I guess, curiosity or that motivation to translate these things to more practical aspects, you're gonna have a hard time. Yeah, it's really what the degree is built around. And then one piece of advice, support group. Like, look at this. Like, I just can I have some answers? And it's like, boom, answers, right? 2 years back, if I asked for some answers, I wouldn't even know who to ask. But even if you just have 2 or 3 really smart friends or decently smart friends, they don't need to be super smart, right? They can just be all right. But you have someone to, like I said, bounce ideas off. I think it's super important. I was really impressed with this one too. Check that out. I typed that one up. But anyways, right? Support group, super important. And that's why some people actually just choose the degree that their friends go into, and there is no shame, there is no harm in that. I think that's super good as well. Having a support group is very important. And obviously that just builds into networking and everything like that, right? And obviously the last thing, just if you don't have direction, that's fine. I didn't have direction until like second, third year, and that's fine, right? But if that's you, right, pick something super broad, right? So that don't lock yourself down. I hear some students telling me, oh, I want to do this double major, triple major, this, that. I'm like, how do you even know what the heck that even means? Like, do this, right? Do something vague so you get a nice touch of everything. Like in electrical engineering and a lot of engineering degrees, they build it so the first, second, and third year, you get to dabble in a little bit of everything. And then towards the end, you're like, oh, you know what? I actually like this one. And you can choose that one, right? So don't lock yourself down too early. Keep your opportunities open. But that's pretty much it. Any questions in electrical? I know we've already talked about engineering quite a lot. Cool? Awesome. Thank you.